Hi, grade 10s. Here's the video for lesson 5 of unit 6. And in this lesson, we are learning about a different type of equation for a graph, and that's called slope-point form of an equation. So we have already learned about the explicit form of an equation, or a linear function is another way of saying a graph, okay? So in the last couple of lessons, we talked a lot about explicit form. And explicit form is always y equals mx plus b, where m, the number in place of m, is our slope, so our rise over our run, how much we hop. And then the number in place of b is our y-intercept, or where we cross the y-axis at. So if I ever gave you an equation like this and said graph it, you would start at the y-intercept and then you would just use your slope to find the next point. So that's one way of doing it. There is another way, and this way is called slope-point form of an equation. And it's called slope-point form because literally this equation will give you the slope and it will also give you a point on the graph. And the equation looks like this: y minus, and then there will be a number in place of y1 here, equals m, and then open up the bracket, x minus, and then in this place will be another number. So the y1, the m, and the x1 are actually going to be replaced with numbers, but this y and this x stay as a yx. Now, m, just like in this graph, m will represent slope. So the number we see here will be your slope. So m represents slope. But this is where it's different, and I'm going to zoom in a little bit so you can really get this clearly, okay? If we take the number x1, the number that's here, and if we take the number y1, the number that's there, and we put them in a coordinate together, this will represent the coordinates of a point on the graph. So again, we take the number that's here, plop it in the front spot. We take the number that's here, flop it in the back spot. And then another thing we have to do is we have to use opposite symbols. Okay, so if it's a negative here, we'll actually write a positive in the bracket, and vice versa. If it's a negative here, we'll actually write a positive in the bracket. So we always switch the symbol when we pull the numbers out. But once we do that, this coordinate right here will be a point on the graph. So we know if we found that point on the graph, we could draw a dot there and then use the slope we were given to find the next dot. Okay, so we're going to practice, don't worry. It kind of sounds complicated, but really isn't. So here it says, from each equation, determine the slope and the coordinates. Sorry, one second. My son just came out of his room. Sorry. Okay, sorry. So from each equation, determine the slope and the coordinates of a point. Okay. So here's the equation. It is in slope-point form, right? I told you the y and this x wouldn't leave, but then these would have numbers replaced for them. So I've replaced y1, m, and x1 with numbers here, okay? I wrote the equation over top so we can see the number here is the y1, the number here is the m, and the number here is x1. And all I'm asking for is tell me what is the slope. So the slope is the number in front of the bracket. That's how I always think of it. The slope is just the number right in front of the bracket. So my slope is negative 2/3. Now, to figure out the point, we open our brackets to make our coordinates. The number that goes here is the number in the x1 spot, and the number here is the y1 spot. So I go to my x1 spot, which is the very last number, which is a positive 4. But remember, I write negative 4. I use opposite symbols. And then to find this coordinate, this number, I go to the y1 spot, which is here, which is positive 2. But again, I flip the symbol. So I pulled out the point negative 4, negative 2. And that's the information I can use from this equation. Here, B, exact same thing. Okay. Again, the slope's in front of the bracket. So my slope's 3, 5. That's easy to find. The point, I go to my x1, which is this number. That always goes first, but I switch the symbol, so negative 2. Then I go to my y1 number, and it's negative 1, but I write positive 1. So again, always switch the symbols. Let's do a couple more. Make sure you really got it. Here, there's no brackets. So like I said, the slope is always the number in front of the bracket. And what have I always said to you guys? If there's nothing there, it's actually like there's a 1 there. So the slope here is really the imaginary 1. So we can write that down. Then the point is, remember, the very last term is our x value. So I flipped the symbol and wrote -3. And then my y value here is from the front of the equation, the -7, which becomes +7. And finally, my slope here is the number in front of the bracket, -2. And then my point is the x value, switch the symbol, +4. And then my y value, switch the symbol, -2. Okay, so now we're actually going to practice drawing. So I'll zoom in here. These questions say draw the graph of the equations A and D. So I'll do A here and D here. So for A, this is what I did. First of all, if we go back to equation A, this is the information I pulled out. I have a point that's -4, -2, and I have a slope of -2/3. So that's the information I'm using. So I rewrote it here. So here, be careful. When you have a slope of a negative slope, you can choose for that negative to go with the top number, or you can choose for the negative to go with the bottom number. It's whatever you want. If you put it with the top number, that means you're going down 2 because the 2 is negative now. But because you kept the 3 positive, that's to the right. If you put the negative with the 3, that means the 2 is positive, so you're going up 2. But because the 3 is negative now, you're going to the left 3. So my point was -4, -2. I found that on my graph. So I went -4 on the x-axis, and then -2 on the y-axis is right there, that big red point. Now, if I choose to do this one first, -2/3, -2 means down 2. So I went hop, hop down, but then to the right 3, 1, 2, 3. And I just did it one more time for fun. Down 2 to the right 3. If you chose to do this one, you'd go to your starting point and you'd go up 2, but then to the left 3. And that's the other point. And then you connect the dots and you've got yourself a line. Then I asked you to do D. So the information we found from equation D was a slope of -2 and then a point of 4, -2. Now, when we're talking about slope, remember slope is always rise over run, right? It's always a fraction. So if my slope was just -2, you have to create a fraction by putting it over 1, okay? So again, you have the option here, put the negative with the 2 or put the negative with the 1. It's whatever you want to do. The starting point is the point we found for -2. So 1, 2, 3, 4 on the x-axis, but down 2. That's my starting point. And say you use this slope first. That means you go down 2 because the 2 is negative, but to the right 1 because the 1 is positive. However, if you chose this guy, you'd start at your starting point and you'd go up 2 because the 2 is positive, and to the left 1 because the 1 is negative. Either way is fine. I don't care. Connect the dots after and you've got yourself a line. Okay. So now for this one, write the equation in slope point form with the following information. So now I'm doing the opposite. Now I'm giving you the pieces of information and you have to put them into the equation. So it's not so bad. So I tell you the slope is -2/5. So I know that that's my M. And then it passes through the point -4, 6. So I know the -4 is the x value and the 6 is the y value. So when I plug it into the equation, I know I always start with y and then my y value, which is 6. But remember, we always switch the symbol. So if I got a +6 here, it must have been a -6 in the equation. Equals your slope, -2/5, and then in brackets x, and then your x value from your coordinate is -4. So I switch the symbol, +4. And there's the equation all done. Again, just one more for practice. Again, slope is 15. So I put that in my M spot. And then my x value is 2. I flip the symbol and put it with the x. My y value is -3. I flip the symbol and put it with the y. Okay, this guy right here. So for each one, you have to determine both types of equations. So slope point form is the one we've been talking about. So I have to determine the equation in this form. And then I also have to determine the equation in explicit form, which is one we've been talking about the past couple of days. Sorry, I should zoom out a little bit. Okay, so for this one here, here's my graph. I give you a graph here with a big line and I have 2 dots drawn in for you. So to figure out slope point, all I need is the slope and a point. So I can easily figure out slope. I travel between my 2 dots. To get from this dot to that dot, I went down 8. And we should know by now that down means negative and to the right 8. And to the right means positive. So my slope is negative 8 over 8. Negative 8 over 8, which reduces to negative 1. That's my slope. And then for the slope point form, all I need is 1 point to plug in here. You have 2 points given to you. You can choose either one. I'm using the point 2, negative 1, but you can very well use this point. It doesn't matter. So if I use this point and I plug my equation in, I have y, and then my y value from here, which is actually going to be positive 1, because I switched the symbol, equals my slope, which is negative 1. And then in brackets, I have my x with my x value I'm using, which is positive 2. So of course, I write negative 2. For explicit form, all I need is my slope and my y-intercept. So my slope, we already found, is negative 1. So I put that in that spot. And then the y-intercept is where your graph crosses the y-axis. So if I look along my red line here, it crosses the y-axis right there, which, look closely, it's the second tick up, right? But if you look at these values, this is 2, 3, 4. So we actually use 2 ticks to jump 1 unit. So if we go down 4, tick, tick, 3, tick, tick, 2, tick, tick, 1. That's the value of 1. That's where I got that from. And all done. Now, this one is a little bit trickier. Stay with me. Try to stay with me, okay? Instead of giving you a graph, I'm giving you 2 points. So again, to determine either equation, we have to figure out the slope. To figure out the slope when you've just been given points and not a graph, you use this formula, okay? And we've seen this before. So I give you 2 points. This is my first point, so it's x1, y1. This is my second point, so it's x2, y2. And then you just plug the appropriate values here. So y2 minus y1 would be 3 minus 4. And then x2 is 6, that goes first, minus, and then x1 is that value, negative 2. So be careful, you have 2 negatives there. When you simplify that, you have 3 minus 4, negative 1, and on the bottom, 6 plus 2 is 8. So my slope is negative 1, 8. So now, to figure out A, my slope point form, this form right here, I plug the slope in, and then I just need a random point to put there. I wrote here, I used the point negative 2, 4. I used this one because it came first. Don't think too hard about it. You can use that one if you want. No big deal. So I plugged in my y and then my y value, which is 4. So I changed the symbol to negative 4 equals my slope, negative 1, 8. And then in brackets, x plus 2, of course, because it's negative here, we flip the symbol. Now, here's the tricky part. Try to stay with me. To find explicit form, this guy, we need the slope, which we already found, so we're halfway there. But then we also need the y-intercept. We need to know, where does the graph cross the y-axis at? Well, we don't have the graph, and I don't really want to draw it. I don't know about you. And there is another way to find the y-intercept, and we talked about this in the last couple lessons. To find a y-intercept, you can substitute x with 0. So in the equation we just developed here, I'm plugging x in with 0. So that's this first line right here. I recopied the equation, but then where there was an x, I put in 0. And I simplified. Well, 0 plus 2 is 2. Okay. Then next I have to multiply that together. So when you're multiplying fractions, imagine there's a 1 down there. You just multiply the tops, so 2, and multiply the bottom, so 8. And of course, there's a negative still going to follow us. Then I have to figure out what y is, right? That's my goal. What is the y-intercept? I have to isolate y. So that's why I actually added this 4, so they canceled out. And I'm going to add it to this side as well. So that's where this plus 4 came from. Now here's the problem. If you have a fancy calculator, you can just go negative 2 over 8 plus 4, and it will tell you what it is. If you don't have a fancy calculator and you have to add a fraction to a whole number, you have to turn this whole number into a fraction that has the same denominator as this guy. So if I turn this into a fraction, I put it over 1. But if I want the same denominator, I have to turn it into an 8. So I multiply by 8. And what I do to the bottom, I have to also do to the top. So negative 2 over 8 stays. But this fraction just became 32 on top because 4 times 8. And then 8 on the bottom because 1 times 8. And then now I just simplify. I do the top. So I have negative 2 plus 32. And negative 2 plus 32 is negative 30. And remember, when you're adding fractions, you do not add the bottoms. It remains an 8. And then all I did here was reduce the fraction by dividing out a 2. And I got negative 15 over 4. Or if you want, negative 15 over 4 is negative 3.75. Okay, so we did get a decimal. That means the graph wouldn't cross exactly at negative 4. It would cross a little bit below negative 4. Or I guess we're talking negative, so it cross a little bit above negative 4. Don't worry too much about that. We don't have to graph it. So we found our y-intercept to be negative 3.75. That's where it would cross the y-axis at if we were to draw it. And now we just plug it in. So explicit form, y equals m, my slope, x, and then my y-intercept tacked at the end, negative 15 over 4. And then you're all done.